Hello, you're listening to Inside iOS Dev, a show about real-world iOS development, here with your host, Andrew Rohn.
And Alex Bush.
And today you're here with a very special guest, John Sundell, and my allergies as well. Sorry if my voice sounds a little different. John Sundell, we're going to be talking about him today, about unit testing as the topic. But about John Sundell himself, he does it all. He's a freelance developer. He posts, you probably know him from his weekly post on swiftbysundell.com. He's also host of Swift by Sundell podcast. He was formerly a lead developer at Spotify until 2016. He's contributed to many open source projects. Interestingly, and then digging through his LinkedIn, I saw he was the CEO of a sales and marketing company at the age of 21, which I thought was quite interesting. I thought I'd throw that in there because I thought that was interesting. I didn't know that. But so that's John in a nutshell. John, is there anything else you wanted to add or just say hello?
Hi, everybody, and thanks so much for having me on the show. You have done very, very thorough research, I must say.
Yeah.
So that's a bit about me, and yeah, like Andrew said, I also do a lot of blogging, podcasting, things like that. I love to share my work with the community, so always happy to be a guest on other people's podcasts as well to talk about different topics. So really, really great to be here.
Yeah, great. Thanks for joining us, John.
Yeah, we're glad you're here. So yeah, and today we have you here to talk about unit testing, which is unfortunately maybe less now, but it used to be a controversial topic in iOS community. So let's maybe start with definitions. What is unit testing, and why should we care?
Right. Yeah, that's a good question. So unit testing is basically the idea that you write a separate program to test your program. So instead of just relying on manual verification of different features and bug fixes and things like that, you rather write a series of tests that is usually called a test suite that basically jump into your code and runs different functions, runs different API calls, and then verifies that the right output comes back. So in a nutshell, it's kind of a way to write code to test your code.
Right. So essentially what normally people would do, right, including myself, before I start testing, you would write some code, right, in your view controller, let's say view did load or something like that, right? And then you hit run and your simulator fires up, and then you have to click through it multiple times, right, to get to that view controller you just changed, and then sort of verify if it works, or logs even with prints, right? So with unit testing, exactly. It's different.
Yeah, it's a bit different. I mean, you still need a little bit of both. You need, of course, still like manual QA. You need to run the app to test it and, make sure everything works and that things look the way you're supposed to. But unit testing is a great way to get a way quicker feedback loop when you're writing code. So like you say, instead of manually kind of going in and clicking a button and making sure that the right thing happens, you can instead programmatically call that function that was going to be run when the button is tapped, and then verify that the right things happen. For example, one thing you could do is, let's say that you have a button that kind of makes some network requests in order to post a comment on a post or something like that. And with unit tests, what you usually do is you inject some special code that is called a mock, where you are basically capturing some of that data. You might, in this case, be capturing the network request, and then you run that function to send that request. You capture the request, and then you write a series of assertions to actually make sure that the request looks exactly like you expect it to.
So actually, yeah. So maybe let's step a bit back and talk about what we just talked about is sort of a technique of it, right? But what is the unit in unit testing? What are we typically would want to test?
Yeah, that's a good question. So When writing automated tests, you can write them in many, many different fashions, and there are many different types of tests that you can write. And unit tests in particular are about testing one unit of code. So that could be one function, one class, one type, basically. And usually what you want in a unit test is you want things to be very predictable when it comes to the outside world. So I just mentioned mocking as an example where you want to make sure that all the things that your function or class uses from the outside world is as predictable as possible so that you can focus on testing just one unit of your code. That might be like you might have some code to load objects from a database and you're just testing that. You're not testing your serialization. You're not testing your caching. You're not testing anything like that. You're just testing the database itself.
So the mocks you mentioned, how are you using them within your tests?
So there are a couple of different ways you can do mocking, and you need a bunch of different kind of mocking techniques, I think, at your disposal in order to write kind of good tests or to be able to work with tests in a nice way. And one of the ways, which is probably like the easiest one, is to have a protocol that you depend on. So for example, if we're talking about the networking thing again, which, is a very common example when you're talking about unit testing, because it's a kind of a challenge to test code that relies on networking, because you don't want to run the real networking code. Like I mentioned before, you want to just test that unit that is using the networking code. So one way of mocking in this case would be to define a protocol that contains all of the kind of methods that you might be using from the network. Let's say you have a method to create a request and maybe one method to perform that request. So you define those in a protocol. You might call that like network engine or network manager or what have you. And then in your tests, you can implement that protocol in a specific class that's only used by your tests, that instead of actually doing the network request, instead of actually performing it, it just captures those values. It just captures maybe the URL and the arguments, and then you can verify that those were indeed kind of the right ones that you expected them to be.
Right. That makes sense. And I'm assuming that protocol, you're using it inside of that class, that object, that unit that you're testing, right?
Yeah, so in order to use a mock, you need another technique. And this is one of the aspects, I think, of unit testing that kind of sometimes makes it a little bit hard for people to get into, is that you need to kind of learn about a couple of different techniques in order to be able to use testing in a nice and kind of productive way. And this other technique now that I'm talking about is dependency injection, where in order to actually have your class or function or what have you use that protocol that you defined, you need to inject that. So you need to, instead of relying on like a singleton, for example, where you say URL session.shared or network manager.shared, you are instead injecting and defining like, here is the network manager you're supposed to use, instead of having that being accessible like globally.
John, I have a question about the protocols, maybe a couple here. So one is, wouldn't you end up with a lot of protocols? So if you're having to write a protocol for probably almost all the classes in your application and it's a non-trivial application, sounds like a lot of protocols and just extra paperwork to keep up with. And then the other question I have is, doesn't your just regular class define an interface that you can test against? What does the protocol give you? Like, what's the benefit of it versus just not creating one and just using the class's interface?
Right. So I'll start with the first question there. Like, don't you just do a ton of extra work in order to enable testability? And yes, that is true in one sense. You will do extra work if you want to make all of your code testable. It's easy to kind of take these shortcuts, as I call them, where you use singletons and you rely on globally shared state and these kind of things to do your work. And those kind of techniques can be really convenient and nice because, yeah, like I mentioned, they're a little bit like shortcuts. You are kind of taking a shortcut into access something that is kind of just globally available. But by defining protocols, by injecting dependencies, and by having all these kind of things set up, it's not just unnecessary kind of boilerplates. Because one thing that making your code testable kind of gives you as a bonus, if you will, is that it's actually a great tool to have more clearly defined dependencies in your app. So a lot of people are arguing about different kind of architectural patterns and how to manage your dependencies. Should I use MVVM or Viper or MVC or whatever? And I think that testing in general is actually a really, really powerful tool to give you kind of a better architecture and give you a more well-defined relationship, because all these protocols, what they do is that they define more clear interfaces between all your different parts of your code so that it's easier to replace things become more modular, and you have this more like well-defined structure where you say, oh, my cache actually depends on my file manager, and my cache also might depend on like some kind of date provider in order to give me a date to cache until. And instead of just having all that inline floating around in one kind of type, you have that clearly defined kind of on the interface level. So it is extra work, but I think in many cases it's worth doing, not only for testability, but for also more well-defined relationships between objects and kind of a more clear architecture overall.
That makes a lot of sense, and yeah, it's kind of sort of that way of doing things and testing pushes you towards that, right? Because otherwise
exactly.
you cannot test, so you're sort of forced to define the protocols. But so what I'm curious, how people, you work with different people on teams, right? And they have different backgrounds and habits, if you will, even. How do you get your team on board in with testing, right? With unit testing, because some of them might say, "Oh, no, but I love my singletons, right? Like it's so convenient."
Yeah, don't take my singletons away from me. You can pry them from my cold dead hands.
Yeah.
Exactly. Yeah. So I think a lot of it comes down to a certain amount of kind of pragmatism. That's one part. And the other part is kind of like showing rather than telling. So number one, I think a lot of people are kind of shying away from tests because it tends to be this thing that people talk about in very like absolute terms, where some people, they are super, they love tests. They are super pro kind of TDD, test-driven development. Everything should have tests. And then on the other side, you have people who, they just want to use singletons. They don't like tests at all. And I think the kind of balance in the middle is where you'll usually find the most productivity and kind of the most bang for your buck. So that's kind of one angle of how I kind of attack this problem, is not going into a team and saying, now everyone should do TDD, because that would just be crazy and it wouldn't match kind of this team's existing culture. But instead, just like trying to start applying tests wherever it makes sense. And the second part there is the showing rather than telling. So as a freelancer, when I start working with a new client, usually they might already have an existing code base, and a lot of the times they have zero tests, like there are no tests in place. And I could, of course, go in with this absolute approach and say, well, if you want to hire me, then you're going to give me 2 months to just write tests. But then I probably wouldn't have any clients. So it's a lot comes down to just like starting to show, if I work with other developers, kind of just start introducing tests in the code I write, and kind of just showing them through pull requests, through a code review and these kind of things, why I think that tests are really valuable. Because I don't write tests just for the sake of it. Like for me, it's a tool in order to create more predictable quality and to kind of have a nice layer of protection for my code and for the logic that I write. And that's kind of what I do. I try to show kind of the value of tests rather than just going in and saying, let's do testing because it's awesome.
Right. Yeah, that's sort of the approach I take myself as well. Test the part of the code. If there are no tests, test the part of the code that you're changing, right? And then change it. That sort of
exactly. Yeah, it's kind of the scout rule, right? Where you try to leave a piece of code better than how you found it. So if you find a part of the code base that is not tested, that could really use tests. For example, if you're fixing some really tricky bug, or you're always having quality problems with a certain part of the code, trying to just apply some tests as you are adding new features, as you're refactoring, can be a great way to start.
And something you mentioned as you were talking about it, TDD. So can you talk about that?
Yeah, sure. So TDD, like the classical definition of it, is test-driven development. And the idea is that fundamentally it's kind of like you should start writing your tests before you actually write the implementation. And the idea is that by doing that, you basically write the test. It fails, of course, because you haven't written the implementation yet. And by doing that, you end up with a higher test coverage because you're always starting with the test first. And as the name implies, you're kind of letting the tests drive your development. So you are going to end up with a lot more testable code, and you're going to have a lot more tests because, well, you wrote the tests first. So that's kind of how it usually works. And like I hinted at before, I think TDD can be a great tool for certain tasks. Like if you're writing a pure function that is some kind of algorithm or something like that, where you have very, very well-defined output that you're looking for, writing the tests first and then doing the implementation can actually be pretty nice. But usually this is not how I personally work. I tend to use tests more like a verification tool. So I usually joke and I say that for me, TDD, it stands for tactically deployed development. So it's not about this kind of, absolute view of things that everything should have tests, but rather tactically deploying them where they make the most sense.
I feel like this is a good point for you to kind of jump in, because I think Alex is has a stronger TDD stance than what you've just explained, John. And maybe Alex, I feel like there's a question in there asking like, well, I think so. There are some TDD, like, what's the word? I say enthusiast is maybe the nice one.
Yeah, exactly.
If you're unit testing without TDD, it's all worthless. Like, it's pointless. You're not doing it right.
Mm-hmm.
What do you think of that? And Alex, maybe, I don't know, maybe you can phrase it better because you might know better. If not, you can just answer that. Like, is TDD worth it? Is unit testing worth it without TDD, or are you losing a lot of the advantage?
So I would be, I'm the person on the other side of the spectrum, right? That you, John, mentioned. I'm the one who's, doing the TDD, right? The test-driven development. And if I can write the tests first, I find that this forces me to think through the interfaces and the APIs and the kind of the things, the side effects that, let's say, that I'm testing ahead of time before even I have the code. And quite often which is sort of what you mentioned previously, right? It kind of makes you realize that dependency, my storage thing, but it depends on this cache sub-level object, right? That I never ever even thought of before, writing the tests. That wasn't in my head. I could not envision that. So it sort of, what it allows me to be is a bit stupid, right? I don't have to keep it all in my head. I don't really know how I'm gonna build this thing, and I don't need to know ahead of time. I can just write some tests and I guess I'm missing this part. Let me write that part, right?
Yeah, absolutely. So I think both kind of ways of working are really valuable, and they have pros and cons. And at the end of the day, it's like whatever works for you and your team is going to be the best approach. And I always encourage people to experiment with different ways of working. And TDD for certain teams and certain tasks can be awesome. Like you say, it has the big benefit of generating more testable code because you are thinking about testability all the time because you are kind of dogfooding it as you go. Mm-hmm. But then you have the flip side of that coin, which is that sometimes you have the other way around, where the implementation kind of suffers because you focused a little bit too much, maybe on the testability angle or on the kind of this well-defined APIs, where a more kind of dirty and not so perfect API would have actually been better in this case if you look at it from kind of a very pragmatic angle and looking at it from like, we all have deadlines. We all have to ship our code at some point. Some of us work with clients and things like that. So I think all the different ways of working has pros and cons. And I like TDD as a concept. I do a lot. And I would say that the way I work is close to TDD. But again, I try to find a nice balance between always writing tests and kind of writing them where I feel like they give me the biggest value.
Right. Yeah. Yeah. That's a very pragmatic way of going about it. What I one thing I wanted to talk about, sort of more kind of concrete. We went through a few examples, right? But how should I put it? What is typically, let's say you start to write a new unit test, right? And let's say you use exit test is one of the tools, built-in tools in iOS platform for that. What would be the structure, if you will, of your tests? Because let's say I'm a beginner, right? And okay, my boss told me write tests now. How do I go about it, right?
Right. Yeah, that's an excellent question. And like I mentioned earlier, it can be really intimidating at first. Even if you're a really senior developer, you have a lot of experience, or maybe you don't, it really doesn't matter, because testing is a very different kind of thing. And you're going to encounter some kind of stumbling blocks on the way. And that's something that I think everyone needs to be prepared for if you've never written unit tests before, to kind of, have that mindset, that kind of learning mindset, that you need to kind of relearn some things and to try out the different patterns. But in general, the way I usually recommend to start is to start with a very kind of rigid structure. So usually the structure that I recommend is called given, when, then. And the idea is that for every test method that you write, so your test case that you write, which is a class, which is a subclass of XC test case, it will contain all these different methods that will start with the word test. So you'll have like test user can log in, test post gets cached, etc. So you will have all these different test methods. And then inside of those, I follow this given, when, then structure. And the idea is that you start by setting up your state. So for example, if you're going to test how a image gets cached in an image loader, you might start by creating an instance of the image loader, maybe creating a network mock like we discussed before, and maybe creating the image that you're expecting, like the expected image. And then in the when block, like in the when section, then you perform the action that you want to verify. So in this case, it would be loading the image. And then in the then section, you basically put your asserts. So just like how you might have used asserts in your code, like when a code path gets hit that shouldn't really be hit, you have asserts in tests as well. And these ones start with XCT assert. So you have like XCT assert equal if you want to verify that two objects are equal. And there you might, in this example, verify that the image that was loaded equals the expected image, for example. So that's usually the structure I recommend. Again, it's not kind of a silver bullet. Sometimes you need to deviate a little bit from the structure, but for starters, I think it's a pretty nice way of organizing test code.
This is actually a really good example. I want to dig a little bit deeper in it and maybe sort of change it a little. So let's say in this case, you have as you described, you have your given, when, then structure. So the given part is where your sort of prerequisites are, right? And your instance, what is it called? Unit under test or subject under test, I forgot, is created. Then in when block is what happens, right? Like you call a method on it, and in then your expectation. So let's say in this case, what was it? The image loader, and you have a networking object in it, right?
Yeah, something like that.
So let's say you're not verifying the result that the image was image resulted was correct, but let's say you want to verify that the networking was called with the right params. How would you go about doing that?
Right. So then I would use a similar technique to what we discussed earlier when we talked about mocking, where you have some kind of protocol that you've created to kind of have a nice interface to your networking code. So in this case, it might be like perform request, for example. And then in your tests, in your test code, you create a special class that you call, for example, network mock. And then every time that this method gets called, the perform request method, it basically captures that request object. So it stores all those request objects in an array. And then what you can do in your then section of your test is that you can just say network engine or network manager dot requests equal XCT assert equal to the request that I expected it to. And that's one way to write a more kind of pure unit test in this case, where you're just verifying your image loader code. You don't really care about what the network part does. You only care that the image loader itself perform the correct request.
I see. That makes sense. And well, same way you can also simply, if you don't really care about the actual request matching, you can just check the count of number of requests, right? So that you know it was simply called, right?
Yeah, exactly. That's one actually really good way to start. If you want to just write a very simple test just to verify, maybe you have some complex logic inside of this image loader about caching, and maybe you have authentication and things like that, and you just want to verify that the request was actually created and sent. And just incrementing a counter can be a really great way to start.
One more thing I kind of want to add to this example, kind of make it a little bit more complicated, so that we sort of clarify for, again, people who are just starting with testing. Because, I remember that was difficult for me to understand, like, how do I go about it? So let's say, again, the same example, right? We have this image loader, we have network client dependency, and let's introduce another dependency there, a logger, right, of some kind that logs things requested, maybe.
Sure.
So in this case, and in this unit test that we had before, right, we're just testing that the network's called. Do we need to inject a mock of the logger as well, or something else?
It depends a little bit on kind of how we're logging, and a little bit of how, you as the developer prefer to verify things. So there are a couple of different options. One of them would be to, for example, if you have a logger that writes to disk, like maybe it like writes a log file, in some temporary directory or something, you could create a instance of the logger, not a mock at all, but an actual real instance of it, and just have it point to a specific file that is maybe in your test bundle or something like that. And that way you could verify that the right log messages have been sent just using that file and using this exact same code that you're using in production. And whenever that's possible, personally, I really, really prefer that, because that way I can have less mocks, and I can also use my real code so that I can get like a wider coverage of tests quicker. That being said, I know that doing that in many cases, you're kind of not doing so much unit testing anymore. And now we're going towards the kind of integration tests part of things, which is a whole other podcast.
Right. Exactly.
But yeah, so... And another way of doing it, of course, would be to create a mock and to just do the same thing as we would do with the network code, capture all the log messages that were sent and verify them that way. And yeah, both ways kind of work, and it depends on kind of where you want to draw the line between unit tests, integration tests, and how you prefer to verify things.
John, I want.
Yeah,
sorry, Alex. I want to start wrapping up here pretty soon. I have one kind of broad question that we might want to close with this, or Alex, you can ask more if you have another question. But I want to start moving and wrapping up. So John, I'm wondering, why do you think historically, I think there's been a dearth of people unit testing, or at least publicly discussing unit testing in the iOS world? Why do you think that is? And then as a follow-up, what do you think we should do going forward as an iOS community?
So the iOS community tends to follow very, very closely kind of what Apple does. And I know that in Apple, Apple is a huge company. They have a huge community within Apple themselves. But looking from kind of the outside and looking at some of the APIs that we were given, historically, they weren't really designed for testability. We're talking about singletons. We're talking about a lot of subclassing. We're talking about kind of having all these implementations very close to the UI on iOS. Like a lot of things has to do with view controllers and these kind of things. And I think that's part of the puzzle as to why unit testing hasn't been super common. And along those lines as well, it wasn't until like iOS 5 or something like that when Apple actually had a first-party unit testing framework. So it's, relatively speaking, quite modern. And of course, it takes a few years for people to pick these things up. So I think those two things kind of in combination has contributed to the fact that, a lot of iOS developers maybe aren't super familiar with tests. But it's definitely changing. And I know that there's a lot of people who are super passionate about tests within Apple, and I love the changes that they're making to the testing tools and improvements. So things are definitely getting a lot better all the time. But I think as a community also, trying to contribute our own tools, trying to come up with new ideas to make testing easier on iOS, share the knowledge that we have, through blog posts and podcasts and conference talks and all different kind of ways, definitely helps more people get into testing.
Yeah, I agree. I know that kind of noticed the same thing with the Apple APIs. They're roughly speaking, they're just not giving us many protocols, and that's the bottleneck effectively for a lot of testing. But that's a different conversation.
Yeah, it is. But then, you look at something like Metal, for example, which is a super modern API. Just as a few years back, it was introduced. And that's all protocol based, and for good reasons as well, because it behaves so differently depending on the hardware. And that's great for testability as well. Like if you want to test your rendering pipeline, you can do that pretty easily just using like the protocols that Metal gives you, which is pretty awesome.
Right.
Cool. Okay, John, I think we're going to wrap up here. Is there anything else you wanted to add before we close out?
No, not really. I think this was a pretty good just introduction. It's always like this when you kind of do a podcast. I think it's it's a lot of fun, and you can get a good introduction. And if you want to learn more about testing, I have a bunch of posts on my website, swiftbysundell.com. You can go to /categories, and there's a bunch of posts under the testing category if you want to check that out.
swiftbysundell.com, SUNDELL2Ls.com.
Yeah, I was gonna.
That's right.
Gonna say I was checking them out right before the episode. Yeah, and there's a lot. I'm gonna read it.
That's awesome. Yeah, it's one of my most common categories, actually. I write a lot about testing, and I try to write it from a perspective of both from people who might have experience of testing and to introduce maybe some new ideas or just showing how I do things, but also for people who have not used testing before. So, for example, I have a quite recent blog post that is called Refactoring Swift Code for Testability, which is all about like how to refactor your code to support testing in the first place. So I try to do a little bit of both.
Nice.
Great. Thanks very much, John. I think this has been very informative. I learned a few things myself. Check out Inside iOS Dev at Inside iOS Dev on Twitter. Please reach out to us. We love hearing feedback from you guys. And John, thanks for joining us.
Thanks so much for having me. Have a good one.
Bye.
Take care. Bye.